Hi, welcome back, guys. How are you doing? We'll be looking at the concept of standard deviation, group data in this particular lesson. It's not hard, right? So we'll be looking at that. We are going to be looking at a few other things, and then we'll be done, right? So we have this example. Yeah, you see this example, right? So this I 60 to 62, 63 to 65, blah blah blah, up to 74. So how do we get the standard deviation of this particular data? Recall that your standard deviation formula is roots sum of f x minus by x, um, then this one is square divided by sum of f, right? So what is going to be our x? Now our x is our midpoint, so at this point you guys did all of those. Okay, so x, let me just fill in the whole thing. This plus this divided by 2, so you have 61, 64, 67, 70, 73. Okay, as we've been doing this thing for a while, so it's not a problem. So next, we need to find our x minus bar x. So x minus bar x, no, x minus bar x, all right. What's 61 minus, okay, what's our bar x? We need our fx. So who knows? This is maybe the first video someone else is saying. So 61 times 5 is 305, 305. I'll just fill in everything. Do I even have them? I don't even think I have those values anyways. So 305, blah, blah, blah. Just fill everything. I'm going to get the final answer. And it's not hard. So our mean eventually is equal to I think it was 67.45. I don't even remember properly now, but I think it was 67.45. 67.45. Because we've been using this question, for a while. And this sum of frequency, was it not 100? This one was 100. Yeah. Okay, so what's going to be our x minus bar x? So x minus bar x equals so 61 minus 67.45. That's what I'm going to quickly remember. 61 minus, that's going to be minus 6.45. Yeah. So you have minus 6.45. On and on, minus 3.45, minus 0.45. Yeah, remember this was like 2.55 and this was like 5.55. So we're done. So we square this whole thing. It's just the same process. Like it's not difficult. Alright, so x minus by x squared. What's that one? Let I do it. X minus by x squared. So 41.60. 41.60. 11.90. Just square all of these values. Like I don't need to do x minus by x, then come back and do x minus, looking for the absolute value. This is for mean deviation. If I square this anyway, the minus is going to disappear, so no point. No point. Okay, so I can just square this. But if this was for mean deviation, you have to like do this, include it in your columns. So 11.90 square 0.045, then that's going to give us 0.20, 0.20, 6.50, and 30.8. And finally, we have x into bracket x minus bar x square. So 5 multiplied by 41.60, 5 multiplied by 41.60, 18 multiplied by 11.90, 42 multiplied by 0.20, 27 multiplied by this, 8 multiplied by this. So yeah, that's all we're doing. So 5 multiplied by that is going to be 208. 208. 214. 214.2. 8.4. 8.4. 175.5. Then 246.4. And we're done. We get 852.5. So we can get our standard deviation. So standard deviation is going to be equal to root 852.5 divided by 100. So I do, okay, because some of those I am struggling with math a little bit. So this is going to be 8 root 8.525, and then that's going to give us, actually it's a plus or minus though, because it's roots. So approximately plus or minus 2.92. Of course, we just pick the 2.92. Alright, when you root a number, you're going to get plus or minus of the number. So that's it. We're done. So the next one that we need to talk about is finding there are a number of formulas though. When you're dealing with standard deviation, they all like mean the same thing. So once you look at how to find your standard deviation using the assumed mean. So recall that we've treated the concept of assumed mean before. How to use our assumed mean to get our true mean, right? And the formula by x equals the assumed mean plus summation of frequency multiplied by deviation, then divided by sum of f, otherwise known as n. So what we just have to do, we've been given the assumed mean of 67, so we have to go and find our deviation first, and then recall that deviation is x minus a. Like the deviation was meant to be x minus by x, but like is what it is. Since we don't have about x, so we are going to use x minus a. So I'm just going to do a d here instead of writing the x minus a in full, and then what's 61 minus 67? That's going to be a minus 6. 64 minus 67 minus 3, 67 minus 67, 0. 70 minus 67, 3. 73 minus 67 is 6. Then I have FD. So 5 times minus 6 minus 30. 18 times minus 3 is minus 54. 42 times 0 is 0. And 7 times 3 is 81. 8 times 6 is 48. Alright, so we need to add that. When we have that, so what are we going to get? 45 minus 30 plus 54, 0, 81. So we get 45. Right, so we can use that to get our mean. So by x equals 67 plus summation of f the 45 over 100. So this is 67 plus 0.45, which is equal to 67.45. Right, but how do you use your assumed mean to find? So the formula to use that we can use to get our standard deviation with the aid of the assumed mean is a little bit different, right, from the formula. So it's derived anyway, so it's not as if it's that different. So standard deviation is equal to root sum of f d square over sum of f minus sum of f d square over sum of f. So this f d squared, okay, let me look at that. Sum of f d squared, okay, over sum of f. So it's just like the mean of the frequency of the deviation, like frequency multiplied by the deviation squared. So you take the mean of it, take the mean of this side. So which means that we need fd squared. And to get fd squared, that means we first need d squared. So like we first need to go and do d squared like this. Then we finish it, then multiply by f. So you have to be careful, like it's not fd. It is this one that is fd squared. Right, but this one get d squared. So minus 6 times minus 6 is 36. 90936. So with that, you can get our fd squared. So 36 times 5 is looking like a 180. 9 times 9 is 81. 81 times 2, that's 162. Looking like a 162. Looking like a 0. 27 times 9. 9 times 9 is 81. 81 times 3 is 243. Is that it? That should be 243. 243. And then 288. So we've gotten, so just add everything here. Fd squared now. And then we are going to be having 873. 873. Now d squared we've gotten fd squared, then fd, our fd here, then square it. So the sum of fd here, then square it. So standard deviation is now going to equal to root of sum of fd squared, 873 divided by 100 minus um, fd is 45, so 45 squared divided by 100. So we keep on. I think we can just do 873 minus uh, 45 squared, right? So at the end of the day, 873 minus 45 squared is going to give us 8.33, 8.33, and the final answer, give root 8.33, and then this is approximately 2.92. So if we compare that, the mean, now we use the mean at the beginning, so we also got 2.92. Okay, this is 8.53, please. So we also got 2.92, so approximately 2.9. So whether you use the mean or the assumed mean, the answer is still going to be the same thing at the end of the day. So what if we now have questions that don't involve the frequency distribution, that doesn't involve like this table, right? So what if we're just giving some of this is this, some of that is that. So how exactly are we going to approach those questions? So that is the last thing that we have to do today, and then move to a different topic. We've got these two very simple questions to talk about. So for a set of 10 data items, sum of x minus 9 is 7, and sum of x minus 9 squared is 17. Find the mean and standard deviation. I like that. So that's smart. That's smart of you. So you already figured something out. That for the first one, an assumed mean was used, right? So it's already telling that the sum of, so like they summed the whole column already for us. They're telling that the sum of x minus 9 is 7. Fine. So which means our assumed mean A must be equal to minus 9, right? And then, no, A must be equal to 9, sorry. And then sum of our deviation, because this is our deviation, x minus 9 is a deviation. Sum of our deviation, or f deviation, as you may put it, because if it is just like this, then this guy is 7. Okay. And then sum of, this is d squared, sum of d squared. My marker is given up for me. So sum of d squared is equal to 17. Now to find the mean, recall then we're given n, so it's 10 data sets, n is 10. So to find the mean, recall that the true mean by x equals a plus sum of f n. So since we're not given an answer, so fd is same as this. That means each of the numbers add frequency of 1. I think we've spoken about that in the past. So by x equals 9 plus 7 over 10, and this is going to give us 9.7. But 7 over 10 is 0.7 and plus 9, so the true mean is 9.7. Then what's now going to be the standard deviation? Standard deviation is the formula that you use for this, since you are using the assuming, because so sum of d squared over n, or sum of f as you want to put it, over n minus so we've been given, okay, then sum of d square over n. So again, we've been given sum of d squared here, and that's f d squared anyways. So if we put f there, still the same as what we did initially. I've told you that if the frequency of each, when we did the mean, that was very beginning, by talking about means, measure of central tendency. I proved this, that if the frequency of the data set is 1, 1, and all of them, they are appearing just once, right? So if you write sum of fx or sum of x, it's the same thing you're going to get. So yeah, so we continue. Our deviation is equal to root sum of d squared 17 over 10 minus sum of d 17 square rather over 10, then sum of D is 7 squared over 10. So 17 squared minus 7 squared. We know 7 squared to be 49, but then 17 squared. I was wondering what was happening. So this covers the whole thing here. Square. So we've been given sum of this square to be 17. So we don't need to put square again here. And then minus this square. So we have roots 1.7 minus 7 divided by 10. That's 0.7 square. And then this is equal to, let me just go and write the final answer. 1.7 minus 0.49 root 1.21. So the answer is approximately 1.1. So our standard deviation is 1.1. Now we've not been talking about variance since, because standard deviation is this. Variance is r square of the standard deviation. So now that we've gotten our standard deviation as 1.1, so variance is just going to be 1.1 square, which is 1.21. So anyhow, variance is the square of your standard deviation. So that, I guess that's why I've not emphasized it like that much. Alright, so for the second one, it says given sum of x to be 960, sum of x squared as 1800, n is 60, find the mean. Okay, this is also easy. But x is going to be sum of fx, or otherwise known as sum of x over n. Okay, so we have 960 divided by 60, and that should be, is it 13? Can it be 13? 60 times 10 is 600, so it remains 360. So like a 16. It's looking like a 16. So this is 16. So how then do we find the standard deviation? As not hard. So by its own formula is going to be sum of x squared over n minus like fx. Do you understand? Minus sum of, which one were we given? Sum of x squared, and then sum of x over n squared. Now this same formula could be written as sum of x bar, sum of x squared bar, like mean of this, right? Because this is divided by the sample size. So mean of this minus this guy is just going to be sum of bar x square, or sum of x over n is mean, right? Is this sum of bar x now? It's just bar x. It should just be by so there's no sum again. Sum of x over n is mean, just by x squared. So you could have it like this. I have to be checking to be verifying what I was in. Or sum of x over n is mean, so mean squared. So mean of sum of x squared, right? So sum of the mean of x squared. So I mean sum of x squared, then something like that. So it could be simplified, and it could be anyhow. So you have the deviation equals sum of x squared over n. We're giving sum of x squared. Where is it? 1800 over 60. 1800 over 60, then minus mean square. So mean square will be 960 over 60, which is 16, that equals to minus 16 square. Minus 16 square. So equals 0 cancel 0. So 30. Is this 30? 0 cancel 0. 180 divided by, that's 30. This is 18,000. I was wondering, what am I writing? So that's 18,000. Let me go back. Have we used sum of x squared at all? This is 18,000. Because I just know that this is not supposed to give me a negative answer. 18,300 minus 16 times 16 is 256. So root 44 is then approximately um 6.63. 6.63. So our standard deviation is 6.63. Our variance will then be equal to 6.63 square, whatever it gives you. Right. I didn't solve that. I didn't prepare to solve that. So that's it. That's it. It's not difficult. So I was making little errors, but thankfully I've rectified them all. So what we have to do now is our assignments, and then we meet in the next lesson. Here's our assignments. Number one, for a data set of 50 items, so you have sum of x minus by x squared is 8, then sum of fx is 20, so find by x and sd, so find by x and the standard deviation. I don't like writing standard deviation in full, so that's why I just like writing sd. Now number two, they are given mass in gram and their frequency. So here, this is a group data. So you've been given an assumed mean using 258.5 as the assumed mean. Calculate the mean, standard deviation, the variance. So just get used to those symbols. Then B, is the data asymmetrical? That is it normally distributed? Is it not normally distributed? Asymmetrical simply means is the data not normally distributed. So explain. Now there are ways you can do that. Number one, you could decide to calculate the mean, median, and mode that we've done. Something that we've done in the previous lesson. If they are the same thing, then the data is normally distributed. Mean, median, and mode. I showed you an example, right? Now number two is that you could construct a frequency polygon. So when you construct that, then look at it. Okay. How is it positively skewed? Is it negatively skewed? Is it like a bell? So if it's like a bell, normal distribution. If it is skewed, the tail is going towards here or going towards here, then it's asymmetrical. So you can use any of those two differences, right, to answer the question. You're good. Our own is just yours is just to prove whether this data set is symmetrical or asymmetrical. That's all. So thank you. See you in the next class.